Hi, my name is Kirrthiga Mahendran. So my group name for this calculus project is called Harlequin, and this group consists of 4 persons, which is myself, Dina, Sofea and Khalisah. So for this calculus problem-based learning project, there's a total of 16 questions, and my group has been assigned with question 12 and question 16. But before I go ahead with that, I would like to give you a little introduction about calculus and what it has to do with problem-based learning. So what is calculus? Calculus is one of the most important subjects for science and engineering students in university because the use of it is widespread in science, medicine, engineering, business, industry, and many other fields to understand and apply the concept of change and motion. Problem-based learning is defined in many ways, but the most widely accepted definition of PBL is called instructional strategy, whereby students are required to solve a structured problem, which is a real-world problem, by identifying the facts related to it. And unlike traditional approach, which is often conducted in a lecture format, teaching in PBL usually occurs between discussion of a small group of students, and this discussion is monitored by the lecturer or a professor. Later on, the students are asked to brainstorm and discuss about the basic process of the problem and come up with possible solution. The questions that are posed, they act as a trigger for the students in this learning environment and helping them become more skilled in problem solving, critical and creative thinking. Now we're going to go ahead with question 12. So the problem background for question 12 is that we know that to find the area of a pyramid, you need to have the formula for the area of a square and a triangle. So the area of a pyramid has two variables, namely x and y, where x is one side of the base and y is the height of the triangle. Next is the volume formula for the pyramid. The volume formula has three variables, namely h, x and y, where h is the height for the whole pyramid, x is the one side of the base, and y is the height for a triangle. However, the question only tells us to find the volume in the terms of x. So what they're asking is that the variables other than x needs to be eliminated. The results that are obtained need to be differentiated through the theorem 3.5, which is differentiation of product, to get the value of x in the maximum condition. So in this process, if there's a negative value obtained, it should be ignored because the question is asking us to find the maximum value. Finally, once you've obtained the value of x, enter that value into the volume formula to obtain the maximum value of v for pyramid. So the next part is going to be the fila table of question 12. So the facts that we have gathered from this question is that the pyramid has a square base where the sides are x meters long. And the second fact is that the total surface area for the pyramid, which consists of the base and the four faces of triangle, is 72 meters square. So there's a total of 5 ideas that we have generated to solve this question. The first one is list down all the information and variable from the question. The second idea is using different pyramid related formulas to complete the calculation regarding the situation. So the third idea is, after trying out a lot of different formulas, use the correct formula to solve the problem. The fourth idea is to differentiate V, which is volume of the pyramid, to get the maximum value in terms of x. The fifth idea is to draw conclusion based on what has been discussed within the group. Based on question 12, there's 4 learning issues that my group would like to share. The first one is, what is a suitable variable based on the question given? Number 2, how to use the formula in order to solve the problem. Number 3, which formula can be used for the following questions? Number 4, how to get on a conclusion on this problem. Our group needed 4 resources to solve this question. The first one is the internet, the second is a calculus reference book, the third is discussion within group members, the fourth is our lecturer's guidance.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Khalisah Assyazalin binti Zulkifli dan nombor matrik saya ialah AA201096. Di dalam video kali ini, saya akan membentangkan jalan kira ataupun jalan penyelesaian untuk case study 12. Soalannya adalah, A pyramid has a square base where the sides are x meters long and the total surface area consisting of the base and four face is 72 meter padu. Find the volume of the pyramid V in terms of x. If x change, find the value of x so that V is maximum and determine the value of V. Jadi, untuk kes 12 ni, info yang diperoleh adalah surface area bagi sebuah piramid adalah 72 meter padu. Dan soalan ini mahukan nilai V maksimum dalam sebutan x. Okay. Jadi, conclusionnya, dalam soalan ni memerlukan dua formula, iaitu formula area dan volume bagi sebuah piramid. Okey, kita mulakan dengan formula area bagi sebuah piramid dahulu kerana di dalam soalan telah memberikan clue pada kita bahawa total surface area adalah 72 meter padu. Tapak piramid tu adalah segi 4 sama sisi. Jadi, kita ada dua bentuk, segitiga dengan segi 4 sama sisi. Formula luas untuk segi 4 sama sisi adalah panjang darab lebar dan panjang segi 4 itu adalah x. Jadilah x kuasa 2. Untuk segitiga pula, 1/2 darab tapak darab tinggi. Tapak segitiga tu adalah x dan tinggi kita gantikan dengan huruf y. Jadi dapatlah 1/2 darab x darab y. Tapi bukan tu saja. Kita ada 4 muka segitiga. Maksudnya kita kena darabkan pula yang formula segitiga tu, darabkan pula dengan 4. Jadi, bila kita dah mudahkan, dapatlah 2xy. Jadilah kita dapat 72 sama dengan x kuasa 2 tambah dengan 2xy. Formula volume untuk piramid adalah 1/3 darab x kuasa 2 darab h. Tinggi untuk volume dengan area untuk sebuah piramid tak sama. Kalau kita bentangkan piramid tu, kita akan dapat segitiga tu, tinggi dia yang baring tu. Jadi kalau kita angkat pula, y tadi tu, kita angkat pula, dia akan jadi yang garisah sengit untuk kat piramid tu. H untuk piramid bukan yang sengit tu, tapi yang tinggi tu. So, dia berlainan. Tapi, dalam soalan nak, V tu in terms of X. Maksudnya kalau ada sebutan yang sebutan H ataupun sebutan Y ataupun yang lain-lain sebutan, dia tak nak. Jadi, apa yang kita kena buat? Kita kena masukkan H tu. Macam mana? So, H lah jadi kepala kita. Jadi bila kita gunakan teorem Pythagoras, kita dapatlah nilai H tu ialah H sama dengan punca kuasa Y kuasa 2 tolak dengan X/2 kuasa 2. Kita dapat dan nilai ni tadi kita gantikan, kita masukkan dalam formula volume kita tadi. Bila kita dah masukkan, kita dapatlah total dia V sama dengan 1/3 darab X kuasa 2 darab dengan punca kuasa Y kuasa 2 tolak X/2 kuasa 2. Aduh, ada pula Y. Tapi jangan risau. Kan dalam formula area tadi ada juga sebutan Y. Jadi kita tinggalkan Y tu seorang kat depan jadi kepala. Yang lain-lain kita letak ke belakang untuk kita masukkan Y yang ada pada formula volume. Jadi kalau kita tinggalkan Y kat depan, jadi macam ni. Y sama dengan 72 tolak X kuasa 2 per 2X. Okay, nilai yang kita dapat ni tadi, kita masukkan balik dalam formula. Jadi V sama dengan 1/3 darab X kuasa 2 darab punca kuasa 72 X kuasa 2 per 2X kuasa 2 tolak dengan X kuasa 2 per 4. Jadi dalam sebutan V ni semuanya X. Maksudnya kita dah boleh selesaikan satu persatu tanpa melakukan sebarang kecuaian. Okey, kita dah siap dah semua sekali. Tapi kita tak boleh siapkan macam ni je, tak boleh tinggal macam ni je. So, seperti yang kita dah tahu, kalau kita nak cari nilai maksimum ataupun nilai minimum, kita kena buat kaedah pembezaan. Okey. Kaedah pembezaan pula kita nak guna teorem berapa? Kita gunakan teorem 3.5. Tapi kat sini saya gunakan U dengan W sahaja. Sebab tak nak tertukar dengan volume. Okey, dah siap dah tu semua. Kita buat masukkan pula dalam formula kita. Iaitu U darab dengan W prime tambah dengan W dengan didarabkan dengan U prime. Dapatlah dV per dx kita. Okey, seperti mana yang kita tahu, bahawa kalau dV per dx tu maksimum atau minimum, dia sama dengan kosong. Jadi kita letakkan kosong. Okey, sepatutnya dapat dua nilai. Kenapa ambil X sama dengan 4.24 sahaja? Sebab dalam soalan dia minta V maksimum. Jadi kita ambil nilai yang positif saja. Okey, bila kita dah dapat nilai X tu, kita buat masukkan balik dalam formula V kita. Yang V dalam sebutan X tu. Gantikan semua X yang ada dengan 4.24. Jadi bila kita buat masukkan, kita dapatlah 1/3 didarabkan dengan 4.24 punca kuasa 1296 tolak 36 darab dengan 4.24 kuasa 2. Jadi kita pemudahkan, kita dapatlah 1/3 darab 4.24 darab dengan 25.47. Jadi dapatlah hasilnya 36 meter cube.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dina Nuraisya Hani binti Arshad and my matrix number is AA200252. Now, I am going to explain the problem background and fila table for case study 16. Before that, I am going to read the case study first. For case study 16, we have to solve a problem about poles. The case is two poles, one 6 meters tall and one 50 meters tall, are 20 meters apart. A length of wire is attached to the top of each pole and it is also staked to the ground somewhere between the two poles. The question is, where should the wire be staked so that the minimum amount of wire is used? Now, I am going to explain the problem background for this case. After reading the statement given, we found a keyword that could help us to identify the topic that related to this question to make sure that we answer this question correctly. The keyword can be found at the last sentence of the statement, which are the word minimum. The word minimum clearly shows that this question is related to a differentiation topic, which is maximum and minimum. After reading the statement again, we found that the main problem for this case is where should the wire be staked to make sure that we use a minimum amount of wire. Before we start answering this question, we have to look and understand the diagram and the information given first. As you can see in the diagram, there are two triangles, one with a small size and one is larger. I am going to label the small one as A and the larger one as B to make my explanation easier to understand. There are two thick lines at the side of each triangle which represented the pole. The length for pole A is 6 meters while B is 15 meters. There is also a line that connects the top of the pole to the ground. It represents the wire. The wire for A is labeled as L1 while B is L2. Now, take a look at the base of the triangle. In the statement, it said that the two poles are 20 meters apart. The value of A is x meter while B is 20 minus x meter. So, what we have to do is, we have to find the value of x in order to identify the place to stick the wire so that we use a minimum amount of wire. Next, I am going to explain the fila table for case study 16. Fila table consists of 4 things, which are facts, ideas, learning issues, and resources needed. First of all, I am going to explain the facts for this case. The first fact is, there are two poles with different height. One is 6 meters tall and another one is 50 meters tall. The second one is, the distance between the two poles is 20 meters apart. The third fact is, the wire, which are labeled as L1 and L2, is attached from the top of the poles and staked to the ground between the two poles. Next, for the idea, the first idea is, we have to list down all of the information from the question. The second idea is, we have to determine the distance between the wire stake and each pole. This means we have to find the value of x. The third one is, we have to calculate the total distance between wire stake and each pole. To calculate the total distance, we have to find the value of L1 and L2 and add the value of it. The fourth one is, differentiate between the two poles, which one uses the minimum amount of wire. And the last one is, we have to draw a conclusion. Next, for the learning issue, the first one is, how tall is the two poles? The information can be found in the diagram or in the statement given. The second one is, what is the distance between the two poles and the wires? We can identify the distance by finding the value of x. The third one is, how to calculate to get the distance between the wire stake and each pole. For this, we have to find the value of x. The fourth one is, how to differentiate the wire used for each pole. And the last one is, what is the conclusion? The resources that our group needed to solve this case is internet, calculus references book, discussion with group members, and lecturers' guidance.
Next, I will be presenting about the solution for case study number 16. So here this is about poles. So whenever you have received the question, first thing first, you have to take out all the information that is given in the question. So let's see here, we have two poles. One pole is 6 meters tall and another is 50 meters tall, and the distance between the two poles is 20 meters apart. So there is a wire that is stuck to the ground to the top of the pole. So the question asks where the wire should be stuck, so the minimum amount of wire can be used. Okay, firstly, what we have to do is to find the L1 and the L2. So that is the formula for the length. So I'm just gonna write down here, L equals to L1 and L2. And then how do we get the L1 and the L2 is to use Pythagoras theorem, because there is a triangle. So here I have already written, which is square root x squared plus 6 squared for the first triangle, and the second triangle is square root 20 minus x squared plus 15 squared. So calculate it and you will get square root x squared plus 36 plus square root x squared minus 40x plus 625. Okay, once you calculate it, you get the equation for L1 and L2. You can see there's an x in the equation, so we don't want x because we want a whole number for our final answer. So we have to find the value of x. So how to find the value of x? We have to differentiate L1 and L2. So once you differentiate L1, you will get 1 over 2, 2x over square root x squared plus 36. And then for L2, you will get 1 over 2, 2x minus 40 over square root x squared minus 40x plus 625. So once you differentiate the L1 and L2, you can see that you can cancel out the 2. So I'm just going to cancel out. And then you will get x over square root x squared plus 36 plus x minus 20 over square root x squared minus 40x plus 625. So after that, the L prime is equals to 0. So L prime equals to L1 plus L2. So L1 plus L2 is equals to 0. So if once you see this equation, obviously you have to move L2 to the right hand side of the equation. So you will get like this. So from here you can see what we should do, which is cross multiplication. So once x squared is multiplied by square root x squared minus 40x plus 625 square, and x minus 20 square is multiplied by square root x squared plus 36 square. So once you multiply all the equation, you will get this very long equation. So from here, you move every number to the left hand side of the equation and cancel out anything that can be cancelled. So here I cancel out x to the power of 4, 40x cubed, x4 and 40x cubed. And lastly, you will get 625x squared minus 400x squared minus 36x squared plus 1440x minus 14400 equals to 0. So that is the equation after you cancel out everything that can be cancelled out, and then everything that can be simplified, you simplify, and you will get the final equation, which is 189x squared plus 1440x minus 14400 equals to x. Once you simplify all the things that can be simplified, you will get an quadratic equation form. So once you get the quadratic equation, you just insert it into your calculator and you will get x equals to 40 over 7, and another one is minus 40 over 3. So here I'm just gonna write down 7x minus 40 and 3x plus 40 equals to 0. And then whenever you have to pick the x, especially for this one, this kind of question, you have to pick the ones that is a real number. So anything that has the negative is not considered as a real number. So the value of x equals to 40 over 7. Okay, once you get the value of x, insert the x back into the L formula, which is L1 plus L2. So here is the formula. So just insert the x, substitute x back into the equation. You will get the final value is 29 meters. So we go back to the question, which asks us where should the wire should be stuck, so the minimum amount of wire is used. So we got x equals to 47. So in conclusion, we will get minimum wire length used if we stack the wire 40/7 feet on the ground from the top of the pool, because we will get maximum 29 meters of wire use only.